Hello, my name is Julio MOGOLLÓN and I am civil engineering student at La Salle University. I told them about an article that talks about development of rubberized Geopolymer interlude bridge. The rubber generates great effects on the environment such as large carbon dioxide emission when burning. Reuse of rubber preserves the environment from pollution and prevents depletion of natural resources, giving way to sustainable development and allowing the growth of eco-sustainable construction. Um, in addition to the properties that it can offer in comparison to other materials. An example, the compressive strength of mixtures containing artificial aggregates are better than those shown by mixtures containing natural aggregates. Currently, there are already initiatives that implement the reuse of rubber due to many advantages that can be obtained from this. Recycled rubber asphalt. Okay, the RSM response methodology was used. It was sought to determine what was the combination of materials that proved the highest resistance to compression, and the results are observed below. It is expected to obtain a compression resistance of 4. From table 2, it can be seen that the higher molarity of sodium hydroxide resulted in a higher compressive strength, which makes the 19 mole molarity the optimum molarity for the mixture designed in this study. In addition, the higher proportion of alkaline solution to fly ash led to produce the best mix of stretch to the compressive strength objective of 4 megapascals. It can be concluded that the ratio of alkaline solution to fly ash should be at least 0.4 and the molarity should not be less than 10 mol. This is important to achieve adequate competition and avoid any complication that may arise when powering the rubber coated Geopolymer mixture. Figures A and B show 3D response phase graphs and 2D contour graph, respectively, illustrating the combined effects of the alkaline solution to fly ash ratio and the molarity of sodium hydroxide and compressive strength. It can be seen that the increase in the ratio of alkaline solution to fly ash and the increase in the molarity sodium hydroxide sodium led to an incremental increase in the compressive strength of the mixture. According the results obtained from each of the laboratory tests are now shown. First, a dry mixing procedure for rubberized Geopolymer was established and the optimum content of the constituents for rubberized interlocking Geopolymer bridge typical of different specific resistances were reported. The molarity concentration of sodium hydroxide was maintained as 18 mol and a solution ratio of 0.8 to fly ash. The average compressive and flexion resistance were 3.98 megapascals and 0.35 megapascals respectively. The bridge had been rated has now fluorescent and classified as their class bricks that can be used as a no-load material. It is recommended to use nanosilicato increase the strength of the bricks.